Welcome back to the wonderful world of astronomy. We're in Chapter 7, our planetary system, and we're going to look in this video at the outer solar system. You see here, once again, the layout of the solar system. In the previous video, we looked at the four inner planets, or the inner solar system, with Mercury zooming around very fast, then Venus, then Earth, and then the red one, Mars. And according to Kepler's laws, the farther out the planets go, the slower they go. And so now we're going to look at the outer planets. We have Jupiter here that makes its way around every 12 years, and then Saturn, and then Uranus, and very slowly Neptune. And this tiny dot right here above my marker is Pluto. And even though Pluto's no longer considered a planet, I'm going to include it and a few other things in this video. In the previous video, we looked at the terrestrial planets, or the Earth-like planets, Mercury, Venus, Earth, and Mars. And I want you to remember the common features of them. They are the four closest planets to the sun. They are relatively small. They have high density. They are made of, for the most part, solid rock. They have few, if any, moons, and they have no rings. Now we're going to get into the next four planets, the Jovian planets, and we're going to see a contrast with the terrestrial planets. So here we go, the Jovian planets, or the Jupiter-like planets. Jupiter is named after the the Roman king of the gods, and he had a nickname, Jove, and so Jovian means Jupiter-like. And the Jovian planets, also known as the gas giants, are Jupiter, Saturn, Uranus, and Neptune. So here we have Jupiter, Saturn, Uranus, Neptune. Let's take a look at them, starting with Jupiter, the fifth planet from the sun. There's a picture of it. You can see its great red spot right there. You can see its horizontal bands that are either white or brown or khaki. And from the college's telescope on a good clear night, you can actually you can see those features. Jupiter is the largest planet in the solar system. You can see here its size comparison with Earth. It is in diameter about the size of 11 Earths all the way across. Jupiter is, like all the other Jovian planets, a large ball of gas. And when you see these features on it, those horizontal bands, the great red spot, this is just the movement of gas. And the great red spot is actually a big storm. You can think of it like a hurricane. And you can see in these pictures that it changes shape, just being made of gas. It doesn't have a solid shape to it. So it changes shape and size over time. Jupiter's composition is mostly hydrogen and helium. Now, we looked at, in the previous video, the terrestrial planets and saw that they are mostly rocks and metals. So now we're straying from that characteristic and we're going to see planets made of gas. Jupiter is made mostly of hydrogen and helium. Also, I want you to keep in mind that that was my description of the sun. The sun, remember, is 98% hydrogen helium plasma, and Jupiter is about that, 98% hydrogen helium gas. As I said before, it's the largest planet. It's actually 318 times Earth's mass. As of a few months ago, in 2003, it had 95 known moons, although that number is always changing. They're always discovering more and more. It has 4 large moons that are called the Galilean moons. And these are moons that Galileo discovered, and it was a huge discovery to see that there are things out there in space in orbit around something else, so another planet. And it has the great red spot that you saw in the picture earlier. It's a storm larger than 2 planet Earths. It has, over at least the past few decades, been shrinking in size. A few decades ago, it was considered about the size of 3 planet Earths. It seems to be shrinking. Galileo saw 4 moons orbiting Jupiter in the early 1600s, showing that not all objects orbit the Earth. Remember, at that time, it was strongly believed that everything up there in space was in orbit around Earth. Here are some drawings that Galileo made. So from one day to the next, you can see he wrote down the dates of whatever particular month it was. And here he drew as a circle Jupiter and where he saw these dots. And he realized these dots were moons that were in orbit around Jupiter. They were the 4 Galilean moons. Here you can see, to scale by time, the moons going around Galileo. I'm sorry, the moons going around Jupiter. And you can see how the clock and the date are ticking by quickly. January 26, 27, 28, 29, 30. So the days are going by quickly. And the reason I bring that up is just to show you that these moons go around Jupiter in a matter of days. Just like Kepler noticed with the planets, and Isaac Newton later on realized what was going on, that it was gravity that was causing this. You can see that the closer in the moon, the faster it goes. And here is a photograph from Earth from a backyard telescope of the 4 Galilean moons. Here are pictures of Jupiter's moons and Ganymede, which is the largest moon in the solar system. It's actually larger than the planet Mercury. We also have Io, Callisto, and Europa. Here's a video being run forward and backward of Io going around Jupiter, and it's neat to see the shadow that Io casts, so a mini eclipse on Jupiter. In 2006, it was discovered that Jupiter has a smaller red spot, another storm growing on it. It's about the size of planet Earth. In 1994, a comet slammed into Jupiter, and before it made it to Jupiter, it was ripped into about a dozen different parts, each about a kilometer in diameter, and then it slammed into Jupiter. So every one of those kilometer-sized comet pieces made a large scar on Jupiter. And you can see by comparison to Earth size that each of those scars is comparable in size to Earth. Now, it didn't do permanent damage to Jupiter. Jupiter being made of gas, the gas eventually folded in on itself, so those scars were gone after a few weeks. The next planet we come to, the 6th planet in the solar system, is Saturn, also a gas giant. It is most known for its rings, but you have to keep in mind all 4 of the Jovian planets have rings. They're just not as prominent, not as visible as Saturn. So Jupiter has rings, Saturn does as well. Here is Saturn taken at various angles, so it depends on how its tilt is oriented towards Earth, and sometimes we get a very good view of its rings when Saturn is tilted towards or away from Earth, so such as in this top picture. Sometimes we're looking more edge on at the rings and we don't get as good a view through a telescope. And here's a close-up view taken from a spacecraft that was in orbit around Saturn. They are not solid rings, but rather they're actually many, many ice particles, mostly ice particles that are in orbit around Saturn. Saturn's composition, just like Jupiter, is mostly hydrogen and helium gas. Its average density is 0.7 grams per cubic centimeter. What's notable about that is that it is less than the density of water. Water is 1 gram per cubic centimeter. So it is the only planet that's less dense than water. And some say that if you had as you can see in the picture here, a bathtub large enough, you could float Saturn in the bathtub, but it would leave a ring. The rings are made of countless small particles that are very, very small, micrometers to meters in size, of water ice. They're all in orbit around the planet. And last I checked, and this would have been in fall of 2023, it had 146 known moons. But again, that number is always changing. They're always finding other moons. Now, keep in mind, when they discover all these moons around Jupiter and Saturn, we're not talking things the size of our moon. Sometimes they can be even less than a mile, maybe even tens of meters across. They're still considered moons. I want to talk about a particularly prominent moon of Saturn. It's Titan, which is Saturn's largest moon. It is the second largest moon in the solar system. Remember, Jupiter's moon Ganymede is the largest. Titan is the second largest, and our moon is the fourth largest. Titan is the only moon known to have a dense atmosphere. This atmosphere is 97% nitrogen and 3% methane, and the atmospheric pressure is more than Earth's atmospheric pressure, 1.45 atmospheres, which means it's 45% higher pressure than what we have at sea level here on Earth. Here you can see in the picture a size comparison of Earth. Down in the lower right hand is our moon, and there's Titan up above. A spacecraft that went to Saturn looked back and took a picture of Earth and Earth's moon, and so here it is, Earth and the moon. Before I go on, I don't want to forget to talk about where we get these planets' names from. Saturn in Roman mythology was Jupiter's father. In various stories, he's either described as a god or a titan. And so hence the name of Saturn's moon, Titan. Now we move on to Uranus, the seventh planet in the solar system. Uranus is named after, in Greek mythology, Saturn's father, so the father of all the Titans. He was also known as the god of the sky in their mythology. Uranus's composition, remember that Jupiter and Saturn were hydrogen and helium. Let's add something to it. Uranus's composition is mostly hydrogen and helium, but also some simple hydrogen compounds such as water, methane, and ammonia. Methane is what gives it its blue color. Something notable about Uranus, it is tilted on its side. Its axis tilt is about 98 degrees, so it's over on its side and then a bit more tilted than that. It is the first planet discovered in modern times. So since ancient times, people have seen with their eyes Mercury, Venus, Mars, Jupiter, and Saturn. Those were the wanderers that the ancient Greeks knew about. They didn't consider Earth a planet at the time, so we're not counting that in the list. But in 1781, now that they had telescopes, and actually they had had telescopes for about 170 years, William Herschel, who also discovered infrared radiation in the year 1800, but he discovered Uranus. So he found this thing, this dot that was moving across the sky. It actually is said to be visible just barely with the naked eye. You would need extremely clear skies for that. But basically it took a telescope to be able to see it, to be able to note that it is a planet, that it's not sticking in the same pattern that the stars stick in. So it was a planet. And there was a bit of a debate over what to name this new planet because all the known planets had been known since ancient times. The Roman and Greek gods were given those names. But then came the question, what do we name this new planet? And William Herschel, who discovered it, he named it George's star, in Latin, Georgium Sidus, after King George III, for whom he worked. Other people were naming it after its discoverer, so some people were calling it Herschel. But by 1850, it became common to be calling it Uranus. So you think in the progression of the planets, you have Jupiter. The next planet out is Jupiter's father, Saturn. And so it seemed reasonable to name it after Saturn's father in the mythology, so Uranus. Last I checked, Uranus had 27 known moons. Here's a good picture of it. You can see its system of rings around it. And this brings us to the 8th planet in the solar system, Neptune. Neptune was named after the Roman god of the sea. Its composition is hydrogen, helium, and hydrogen compounds, so it's very similar to Uranus. It also has rings, just like Jupiter, Saturn, and Uranus. Something notable about it, its moon Triton is the only large moon in the solar system that orbits backwards. We've looked at this common, what I call counterclockwise motion that most things in the solar system have. The planets all go around in that same direction. The sun rotates in that same direction. The asteroids go around in that same direction. And most large moons go around in that same direction, but Triton is an exception. It goes around clockwise. It goes around the opposite direction as all the common motions in the solar system. So it's believed that Triton at one time might have been a comet, and it got captured by Neptune's gravity. As of this recording, there are 14 known moons around Neptune. It was discovered in 1846, although it was witnessed by Galileo in 1613. So people in later times looking at star charts that Galileo had made noticed that he, in many drawings, drew a dot that doesn't correspond to any stars. And astronomers were wondering, what is this dot that Galileo keeps drawing on his star charts? And then tracing back the motion of Neptune, they realized that he was, through his telescope, seeing Neptune, which is an amazing feat for, given the quality of telescopes back then. A telescope had only been around for about 4 years or so. But he was seeing Neptune, but he didn't discern it as a planet because Neptune moves around the sun very slowly, so he wouldn't have been able to discern its motion around the sun. Now, an interesting thing about Neptune's discovery is that nobody chanced upon it, as I mentioned about Galileo a minute ago. It would be very difficult to notice that it's a planet because it moves so slowly around the sun. So it wasn't discovered by telescope, but rather it was discovered by math. It was Newton's theory of gravity that led to its discovery. As mathematicians and astronomers were using the math behind Newton's theory of gravity, tracing out the orbit of Uranus, they were realizing that there was an inconsistency between where the math said that Uranus should be in the sky and where it actually was. And then they speculated that what might make up for the discrepancy is if there was an 8th planet that's beyond Uranus somewhere, tugging on it gravitationally. So they inserted into the equations a hypothetical 8th planet, and they used the equations to figure out where would that planet be that is pulling Uranus to put it in the place where it is, and that led them right to where Uranus is in the sky. So we've looked at all 8 planets now, and here they are in size comparison. In the previous video, we looked at Mercury, Venus, Earth, and Mars. They're not given here in order of distance from the sun, but rather in order of size. And so Mercury's the smallest, then Mars, then Venus, then Earth. And so much bigger than Earth is Neptune, and then Uranus. But then so much bigger than Neptune and Uranus are Saturn and Jupiter. Jupiter and Saturn And Uranus and Neptune, the Jovian planets that we've been looking at in this video, collectively are called the gas giants, although sometimes Uranus and Neptune are referred to as the ice giants as well. And then, of course, we've seen the terrestrial planets. Look on the right-hand side of the screen, characteristics of the Jovian planets. And I've compiled this so you can see in contrast to the lists that we've previously seen with the terrestrial planets. So now let's compare these two. Terrestrial planets are the 4 closest planets to the sun. Jovian planets are the 4 farthest planets from the sun. Terrestrial planets are relatively small. Jovian planets are relatively large. Terrestrial planets have high density. Jovian planets have low density. Terrestrial planets are made of mostly solid rock. Jovian planets are mostly gas. Terrestrial planets have few, if any, moons. Jovian planets have many moons. Terrestrial planets have no rings, and Jovian planets have rings. You should learn these two lists, understand the characteristics of terrestrial and Jovian planets. Moving on beyond the recognized planets, we go to Pluto, which was a planet upon being discovered, but in 2006 got taken off the planet list, and we'll talk more in the future about why it got taken off the planet list. Here is Pluto with its moon Charon's. Pluto was discovered in 1930, and its moon Charon discovered in 1976. Pluto is named for the Roman god of the underworld, and Charon in the Roman mythology was the man who rode the dead souls across the Styx River to get to the underworld. There's a picture of Pluto. For most of the time that it's been known, we never had any close-up pictures, but then several years ago, it was about 2015, the New Horizons spacecraft, which had taken more than 9 years to get to Pluto, it got there, and we finally were able to see pictures of Pluto up close. And there it is, a notable feature, just a heart on it. Here's an animation of Pluto with Charon going around it. And it's a good example of when things orbit other things. It's not simply a matter of the small object orbiting the big object, but rather they orbit around their common center of mass. Charon has a pretty large mass. It's still smaller than Pluto, but it's comparable in size to Pluto. So you can see the center of mass is right at the center of that circle, and you can see Pluto going around it as well as Charon. It was discovered in 1930. Its discovery was by accident. In fact, its discovery was almost like the discovery of Neptune. Earlier, I described how Neptune was discovered by math, that the theory of gravity, the math behind gravity, led people to figure out why Uranus isn't quite where it should be, and they speculated where this 8th planet should be. Well, there's a similar thing going on with Neptune. Neptune wasn't exactly where the math said it should be. So they did the same thing. They speculated a planet out there beyond Neptune, a massive planet beyond Neptune, and they did the math and figured out where that planet would be, and they found the location in the sky. They pointed telescopes up there, and they found this dot up there, and they said, there's our planet, Pluto. But the thing is, Pluto is not a massive planet. Pluto was actually very tiny. When it was considered a planet, it was the smallest planet. And so they found it by accident. The math had actually been done wrong, but yet they found this thing out there. Later on, it was discovered that there's this thing called the Kuiper Belt, which has many icy objects out there, and we'll talk about the Kuiper Belt in a later video. But they could have looked in a lot of places in the sky and found something and called it the new planet. But they discovered it, they called it a planet a bit prematurely. Then later on, they learned that this thing is actually very tiny. It doesn't have characteristics of a planet. Even when it was a planet, when in the early 2002, 2003, actually in the last few years of it being a planet, and I had no indication that it was ever going to be taken off the planet list, but I taught my classes that it's more like a very large comet. And we just leave it on the planet list. I would jokingly say to my students, so as not to hurt its feelings, we don't want to take it off the list of planets. But then a few years later, it was decided, most astronomers agreed that it more has characteristics of a large comet, and it was kind of complicating things in how we classify objects in the solar system, leaving it on the planet list. And so I can get more into that when we get into chapter 12 on dwarf planets. But it got declassified as a planet in 2006. Its mass is 0.22% of Earth's mass, so very, very tiny. Its composition, it is neither like the terrestrial planets nor like the Jovian planets. It's made mostly of ice, and that includes nitrogen, methane, and water, and rock. It has a very thin atmosphere made of nitrogen, methane, and carbon dioxide. Interestingly, nitrogen is the key component to Earth's atmosphere. And it has 5 moons, including Charon, which I showed you earlier. Here's a size comparison. Here we have Earth on the left, Earth's moon on the right, and then Pluto and Charon right in the middle. So you can see that this thing that was once known as a planet, it is much smaller than our moon. Here's a size comparison of Pluto with its moons. And I'm sorry, this is a size comparison of Charon. You can see the large curvature of it with the other moons that were discovered very close to when it got declassified as a planet. You notice the scale here, 10 miles being this line. So these are very tiny moons. This is a beautiful picture of Pluto and its atmosphere. So remember I said that it has an atmosphere with nitrogen and methane, and its atmosphere, its sky is blue for the same reason Earth has a blue sky, that scattering of the blue light from the sun. So I think that's pretty neat, although it's a much thinner atmosphere. So I don't think it would be a deep blue like Earth's sky is, but still somewhat of a blue sky. We come now to what I consider to be the culprit, the object that led to Pluto being taken off the planet list. And there's this thing, it's known as Eris, and it has a moon dysnomia, officially known in the catalogs as 2003 UB313. 2003 refers to the year it was discovered, and often astronomical objects are named after the year they're discovered, but we've given it the name Eris, and again, it has a moon dysnomia. So in 2003, the first object comparable in size to Pluto, it wasn't this, it was something else, it was called Quoar, was discovered, and it led people to think that, okay, there are things out there in the Kuiper belt beyond Neptune's orbit that are comparable in size to Pluto. And then astronomers were wondering, do we call these planets? Well, they're smaller than Pluto, so we can get away with not calling them planets. But then the thought came up, what if one day we discover, and we probably will, one of these objects that's larger than Pluto? If it's larger than a planet, shouldn't it be called a planet as well? The counter to that argument is we really don't like calling Pluto a planet, and so Pluto really shouldn't be, its size really shouldn't be the standard of what is or is not a planet. But there was the debate, what if we discover something larger than Pluto? And around the year 2006, With further study, it was realized that this thing, Eris, that had been discovered in 2003, was larger than Pluto. So then this debate became real. What do? Do we call it a planet because it's larger than Pluto? And in the end, it was decided this is a good step. Let's slightly change the definition of planet so that it doesn't include Pluto. Then we don't have to call any of these things planets. At this time, they were discovering more and more what's called Kuiper belt objects, objects in the Kuiper belt that are more similar to very large comets than planets. And it was decided, let's just call Pluto a Kuiper belt object. We can also think of it as a dwarf planet, but then we don't have to call all these other things planets. In more recent years, there has been a discovery. Sometimes it's called Planet 9, sometimes it's called Planet X. There is strong evidence that there is a large planet that's out there in the Kuiper belt, way beyond Neptune's orbit, about 600 astronomical units from the sun, which gives it a 15,000-year orbit. Now, there are many, many Kuiper belt objects out there, many large comets, but this is a little weird because it seems to be massive. It seems to be about 10 times Earth's mass, which makes it comparable to Uranus and Neptune. Now, they've discovered it based on its gravitational tug on the comets around it. So there is something out there that is pulling on the comets around it that seems to have the mass comparable to Uranus and Neptune. They don't know what it is. And so further investigation is what they're doing, and hopefully one day soon they'll figure out what it is. There's been some speculation that maybe it's a miniature black hole. That's just very hypothetical and speculative. It probably isn't. Most likely it is a massive planet, but we'll see. That would be a phenomenal discovery to find such a large planet so far out from the sun. And that is the end of our look at the outer solar system, or the planets and planet-like things in the outer solar system. Have a great day.